Okay, so good day class. Our left for this about numerical methods for engineers. So can define first what is a numerical method. So this is considered as technique by which mathematical problems are formulated so that they can be solved with basic arithmetic operations such as addition, subtraction, multiplication, division that can be performed with the aid of the computer. So for the mathematical modeling engineering problem solving, it includes the following, no? So we'll concentrate more on this topic, how to find yung roots ng given equation. So of course, we're considering first degree equation. So we're considering here now mga third degree, transcendental function, etc. Okay? So second part would be the system of linear equation. So already done with this topic using yung Gaussian elimination or Gauss-Jordan optimization. Okay, so ito yung sa calculus, no? Determine the minimum or maximum. Curve fitting, so to pag-curve ng data points, so regression and interpolation. So more on statistics to, no? Then integration, determination area under the curve or volume. And last would be the ODE. Okay, so of course, we expect that computers are considered as great tools. However, without fundamental understanding ng engineering problems, of course, they will be useless. So yung typical engineering problem solving process, of course, ang start niya will be we need to identify what is the problem, no? So to solve this problem, of course, so we need to create, okay, a model, mathematical model that can be derived from the data that we obtain from, let's say, from the experiment or the theory that we use. So from that model, we can be able to extract, okay, numeric or graphical result, no? And from this, we can be able to implement, okay, yung yung result, okay, ng model natin. So for the roots ng equation under the bracketing method, so if we are given f of x, a function of x, and we want to find alpha such that f of alpha is equal to 0, so alpha here is considered as the root of the equation, f of x equals 0, or the 0 of the function f of x. So to find the roots graphically, so this is not an accurate method, no? But however, this method can provide us useful information about the function, kung multiple roots ba siya, continuous function, okay? And of course, we can be able to determine, okay, yung approximate, okay, location ng roots natin. So the following root finding methods will be introduced. So under the bracketing method, we have two: bisection, regular falsi, or false position. Then aside from bracketing method, we can also use the open methods under this. So we can use either the Newton-Raphson or the secant method. Okay. So first day, we're going to discuss yung bisection and regular falsi. So under the bracketing method, we have this theorem. If the function f(x) is continuous in the interval from a to b, and the product of f of a and f of b is less than 0, it means this is negative number, then the equation f(x) equals 0 has at least one real root in the interval from a to b. So for example, so may function tayo na ganito, no? Okay, so we define yung a and b natin. Of course, if we try to evaluate f of a, this turns out to be negative, no? And f of b is obviously positive, okay? So if we try to multiply f of a and f of b, so obviously negative times positive is negative, which is obviously less than 0, okay? So we expect that within this interval, meron tayong root, okay? So this root is this point. Now, usually, kapag yung product ng f of A and f of B is greater than zero, means positive, it implies zero or even number of roots, just like given a figure A and C. Okay, so dito wala, no? Zero. So C is dalawa. Now, if the product of f of A and f of B is less than zero, so meaning negative, it implies odd number of roots. Okay, just like sa figure B and D natin. So isa, this is, we have three roots, no? So we have here exceptional cases if you're given a multiple roots. So roots that overlap at one point. Okay. So for example, if the given equation or function is f(x) equals to this, has a multiple root at x equals to 1. Or yung function natin, okay, that could discontinue within the interval, just like sa given a figure B natin dito. Okay. So discontinue siya at this point. Or from the interval x sub L to x sub u. Lower and upper limit. So for the algorithm ng bracketing method, so first step, we need to choose the 2 points. So usually x sub L to x sub u or from A to B, such that f of A, okay, times f of B is less than 0. Okay. Then we can estimate the root x sub R. So take note that x sub R should be less than x sub u or B, but greater than x sub L or A. Then step 3, we determine which interval, subinterval the root lies. Okay. So if we satisfy this inequality, then we need to set the x sub u to x sub r, then go to the previous step. Otherwise, if we satisfy this inequality, x sub L, we need to set the x sub L or the lower limit to x sub r, then go to step 2, no? Else, if we satisfy this condition, okay, so we can now set the x sub r to be the root for the given equation. So how to select x sub r in step 2? So for the bisection, we need to guess without considering the characteristics of f of x. And second, false position or regular falsy, you can use the average slope to predict the location of the root. So for the bisection, so this is considered as a numerical method for estimating the root of the polynomial f of x. So this is one of the simplest and most reliable, but it's not the fastest method, no? So assume that f of x is continuous, and we have here the procedure algorithm for the bisection. First step, we need to find points A and B such that A is less than B, and f of A times f of B is less than 0. Then step 2, take the interval from A to B, then find the midpoint x sub I. Of course, the formula for the midpoint would be just the average, no? So yung formula natin for the bisection is x sub I equals A plus B over 2. Okay? So yung formula para dito. Now, if f of x sub I is equal to 0, then that x sub I is considered as the exact root, no? Else, if f of x sub I times f of b is less than 0, then we have to let the a lower limit to be the uh, x sub I. Else, if f of a times f of x sub I is less than 0, then we have to set b equals x sub I. So to illustrate this step number 3, so let's try to consider this figure, no? So let's say again, this is our x and y axis, okay? And let's say this is the behavior for a graph or function, okay? And we're given here the interval from A to B. So let's say this is the location of x sub I natin, okay? So for the next iteration process, so we need to set, okay, this x sub I, okay, to be the new A in the next iteration, and this B to be the new B in the next iteration. Okay, since if you try to multiply f of A times f of B, this turns out to be what? Positive, no? And if you try to evaluate yung f of x sub I and f of B, this turns out to be positive. So we expect that the root lies in the within the interval from x to b. That's why we need to set this as the new a and this b value to be the new b. And for this case, so let's say ito yung x and y axis natin, and let's say this is the behavior for a graph or function. This is the interval, and let's say this is the location of x of y. So for the next iteration, we need to set this x of y to be the new b. So we can call this the new b as b prime, and this a as the new a in the next iteration. Okay. So next step, we need to repeat the step 2 and 3, okay, until such time that the f of x of y is equal to 0, or the absolute value of f of x of y is less than or equal to the stated degree of accuracy in the problem. So usually yung value ng DOA is around mga 0.001. Okay? Okay, so example. So let's say we're given here this function or equation fx equals to x raised to 3 plus 3x minus 5. And we're given the interval from 1 to 2. The stated degree of accuracy is 0.001. Okay. So to solve this problem, solve this or determine the root, okay, for this given equation, okay, using the bisection method. So of course, we need to tabulate our values to solve this problem. So we need to create a column for the value of a and b. Okay. So this is given 1 and 2. And of course, to solve for the value of x, so use the formula a plus b divided by 2. So 1 plus 2 is 3 divided by 2 is 1.5, no? And we need to add another column for f of a and f of b as well as f of x. And we need to investigate, okay, yung change ng sign if this happens between a to x or x to b, no? So if we try to investigate, um, of course, we can determine f of a by substituting this one value of a to the given uh, equation. No? So 1 raised to 3 plus 3 times 1 minus 5 is give us negative 1. And of course, f of b can be obtained using the same process. Substitute this b to this given uh, function. Okay, so 2 raised to 3 plus 3 times 2 minus 5 is give us 9. Similarly, for f of x, we can obtain that by substituting this 1.5 to this given function. Okay, so we can add another column for the change of sign. If this happens between, so kung if you try to multiply f of a times f of x or f of x times f of b. Okay, so negative times positive is negative. Tama? And this one positive. So we expect that the root lies in the lower interval, no, between a and x. So for the next iteration, we need to set this value of x to be the new b and retain this value of a as the new a, no? So we expect that this is 1 to 1.5. Then we need to recompute the value of x. Ayan, no? So 1 pa rin, 1.5. So we can recompute the value of x as 1.5 by using the formula a plus b divided by 2, no? And we can obtain the following values for f of a, f of b, and f of x. So investigate the change in sign. So negative pa rin to. this one positive. Okay. So yung stopping criteria natin would be what? So if we reach the condition, ito no, if f of x is equal to 0 or the absolute value of f of x is less than or equal to the stated degree of accuracy in the problem. So for this case, our DOA is 0.001. No? So obviously this value of x, 0.703, absolute value of that is greater than pa, no? The DOA. So in process, we'll repeat until such time that we can obtain the stopping criterion of ito, no? If uh, f of x is the absolute value of f of x is less than the stated degree of accuracy in the problem. So after ninth iteration. So for this case, the answer would be yung value ng x. Okay? So this is the root of the given equation. So this is the final answer. Okay? So for the third iteration, if you try to observe, if you try to multiply this negative times negative, becomes positive, no? And this one negative. That's why for the next iteration, we have to set, okay, the a value, okay, this x to be the new a, and retain the value of b as the new b for the fourth iteration or the next iteration. Okay, so for the second method, regular falsy, this is still under the bracketing method. So this is a numerical method for estimating the root of the polynomial f of x. So value of x replaces the midpoint in the bisection and serves as a new approximation of the root of f of x. So the objective is to make the convergence faster. So assume that f of x is continuous. Then we have the same algorithm or procedure, step 1 to 4. So the only difference is how to obtain yung value ng x of I natin. No? For the regular falsy, so we have this formula, no, that we need to derive. So consider again this x and y axis. And let's say this is the behavior of the given function, f of x. And let's say this is our interval. So this is f of a, f of b, no? So by connecting these two, we can be able to determine the next value of x. We can call the next value of x as x of I, no? So using similar triangles, we can be able to determine the formula for x of I. So this is f of a, f of b. This part is b minus x of I, and this part is b minus a. Okay, so using similar triangles, we can generate this equation, f of b over b minus x of I equals, so this triangle, okay, equivalent to this triangle, bigger triangle na to. Okay, So this is for the f of b segment. This segment is f of b minus f of a. Since we're just after the absolute distance between these 2 points, no? Over this segment is b minus a. So just isolate x sub I to give us a formula b minus f of b times b minus a over f of b minus f of a. Okay, so ito yung formula for the regular falsy or false position. So this is a function of b, a, f of b, and f of a. Okay, so let's try to erase this part, no? So retain lang natin tong formula. Okay, so we have the same given f of x equals to uh, x raised to 3 plus 3x minus 5. A is 1, B is 2, DOA is 0.001. Okay, so we need to tabulate our values. So column for A, the given, B. And of course, to find this value of x, we need to use this formula, no? So we need to determine first what is the value of f of A, f of B, as well as ayan, f of A and f of B lang. So ang B natin is 2. Okay, to obtain this 2 minus f of b is 9, then times 2 minus 1, then divided by f of b is 9 minus negative 1. Okay, so this will give us 1.1. So of course, to determine f of a and f of b, just substitute this two values, okay, to the given function. No? So f of x can be obtained by substituting this value of x to the given function. So for the next iteration, in order to choose what is the value of a and b, so we need to investigate yung change ng sign. No? So if we try to multiply f of a and f of x, or f of x to f of b, no? So f of a negative, f of x is also negative, so we expect that this is positive. F of x times f of b is negative. So we expect that the root lies in the upper interval between x to b. So for the next iteration, so we need to set this value of x to be the new a, and we have to retain the value of b as 2, no? So yeah, no? So we can now uh, determine if we already have the value of a and b. We can now determine what is f of a, f of b. And after that, we can determine the value of x by using this formula. Okay. Then we can determine the value of f of x. Okay. So by substituting this x to the given function. Then if sige the sign, change ang sign. So again, this is negative times negative is positive. And this one, negative pa rin, no? So we expect that this x would be the new a, and we have to retain this value of b as 2. Okay? So yung process na yan, repeat until such time that we can reach this condition. The absolute value of f of x is less than or equal to the stated degree of accuracy in the problem, which is 0.001. So obviously, if you take the absolute value of this, okay, This is obviously less than the 0.001. So we can now conclude that this value of x is the root for this given equation. Okay, so this is the answer. So this is the end of our presentation. So thank you for listening.